Thank you very much. Welcome on our presentation. I'm really happy that there's so many here. I hope it will stay until the end of our presentation, and but we'll see. Today we will be talking about the Metadevops. Maybe you are thinking, what does it mean? So some buzzwords. So yeah, we will try to explain you why we are talking about that, what does it mean for us, and whether it makes sense for you as well. So I will try this one. Today, together with me here is Otto, Klima. He's our technical architect, and we expected Gabriela as well, but unfortunately she's sick, so we need to do it by ourselves. Okay. Okay, that's fine. Okay, so we should start about why we are talking about the Metadevops. What does it mean? So imagine our situation, which we are facing in the past. We joined the project, or you are joining the project, and the project consists of several sub-initiatives, and each of these initiatives is creating some application. Application usually is event-driven architecture. That means tens of microservices. Most of them, they were deployed to the Kubernetes cluster. In some cases, these teams, they were sharing the same Kubernetes cluster, but that was not always the case. And sometimes it was different dedicated Kubernetes cluster. And same was also with the DevOps tools. There was never objective of our initiatives to set up proper DevOps tools. So we had several dedicated approaches. We were using different, or you are imagining, yeah? So you're using, they use different Git repositories, GitHub, Gitlab, Bitbucket. There is Jenkins, where setting up pipelines, but also not the same approach every time. And there are nexuses where are stored your registries, and you have to take care about everything. And there are expectations from your team that you are still focusing on the development of the new application. But after time, you figure it out that you are spending a lot of time on the maintaining existing applications. People on the project are frustrated because it's really complex and it's not easy to even dive in. Learning curve for the new people, it's really hard. There's a mess of technologies. So, and then also from the cost perspective, it costs really a lot of money, and the machines or the CPU utilization was not efficiently used. So you have the situation and you need to think about how to optimize that. Okay, so in order to do that, okay, no worries. We split our problem into three areas. There is a DevOps infrastructure, and by that we mean the infrastructure which is needed to develop the application. So it's for supporting tools, and there is running your Git repository. They're running your quality assurance tools, some quality checks, static code analysis, security checks, and so on. And you have usually one DevOps instance. Then there is a application infrastructure. By that, you can imagine the environment like a develop environment, integration, any kind of tests you can imagine, UAT, performance test, and also production. And the third area is application deployment. And that's the deployment of your application into the application infrastructure. So now, as we have defined three areas, we need to define non-functional requirements for any of you, all of them, yeah? So we start with the DevOps environment. You definitely would like to have infrastructure as a code. That's even more important than for the application infrastructure, because this is done usually once and you are not touching it for months, even years. And if something wrong will happen there and you need to suddenly change it, it can easily happen that nobody remember why it was done in that way, or even worse, the person who did it is not on the project anymore. Yeah. So that's really a crucial part. It's going hand in hand with the reusability, because once you have it written as a code, you can take it and use it for the other clients. That's often our case. And it's also human error-free. There is no space for user typo or overlooking some guidelines and so on, because you tested it before. Just the add-on on top of this one is disaster recovery support. As you have already infrastructure as a code, It's just a small step that you are defining that you can deploy your DevOps environment to multiple regions, and you can take a backup of your existing environment, which is done as well, and you can restore your environment pretty easily. Yeah? We would like to avoid cloud provider lock. Maybe now it's trendy to use some very well-known, I will not name them, cloud providers, but it can change in the meantime. Yeah, maybe after 5, 10, 15 years, you never know what will happen, and the situation can completely change. There could be other cloud provider. There could be even the situation that we will be returning back to the on-prem because of some reasons. You never know. So we'd like to have free of choice, and we would like to have a possibility to, as minimum as possible, effort to change or to adapt to new trends. You would like to have a high available your environment. By that we means that you don't want to rely on one service, which if it will be stuck or crashed, then your whole environment or development team will be stuck. And one of our major objective was significantly decrease maintenance effort and operational cost, because we didn't want to focus on keeping the servers and applications running, and we want to really focus what we were supposed to do. And cost as well, as we were running virtual machines, our costs were really high, and we have to do something with that. About the application environment, it's more or less the base is same as the DevOps environment. There's small difference, and it means that application environments you can have more. You are starting from 0 at the beginning, and you can have till end and how many you need. And we wanted to have that setup control spinning up and spinning down the environment. We wanted to have defined approval process that we are able to see who is requesting the server, when it was requested, what was the size requested, when it was shut down, and so on. And on top of that, we would like to monitor your cluster. Compared to your DevOps environment, which we would like to monitor as well, there are running several applications, and you never know whether it's sufficient, there are some issues with the scaling. And we would like to also monitor the infrastructure state of your application environment. By that means that you would like to know that your server is running and there are no issues with some configuration. And the last but not least is application deployment. This standard automated CI/CD process, including testing, static code analysis. Docker built some container security checks, and on top of that, we would like to have support of multiple environments deployment, because we already have multiple application environments. And we would like to have monitoring, logging, and observability. And observability is really important, because even if your application is or seems to be running and there are no issues in the log, it can happen, especially for event-driven application, which was our case, that from business perspective, it is not working because some transaction is stuck somewhere where we did not expect, and it's not working. We need to look at it. Okay, we were discussing about non-functional requirement, and now we should look on the functional requirement. What we are expecting, what are our needs from each of these area. So regarding the DevOps environment, we need to have environment where we will have our Git repositories. Yeah, obviously. You need to have a space where your CI/CD pipelines will be executed and you will be able to deploy to your application cluster. And you would like to have a space where you store all your registries, container registry or any kind of package registry, Node.js packages or Go packages or Java. And you would like to also have tracking and issue tracking tool and task management, and also some kind of dashboard. And you would like to have also the space where you can document your application, which can be easily indexed, search, and so on. And last but not least, some quality assurance tools like security checks, code quality checks. Okay, why you can, and it's not must. It's in our case, we consider GitLab, and I'm an advocate of the GitLab, so there can be some other circumstances in your case when it doesn't make sense for you, or you make sense something else. So why we consider GitLab? It's open source, at least the community edition, which is sufficient for our case. They're constantly adding new features. There is in several weeks. Every several weeks there is a new major release, and they are releasing security fixes even more often. and there is active development as well. And the main part, which was most important for us, it's all-in-one in our case. So it's replacing all our tools which we used before, like Jenkins, Nexus, Bitbucket, Athens, because we had also some application written in Go, so we had to have a Go package proxy, and also partially Jira tools, Agile tools, Jira and Confluence as well. For us, it was sufficient, and yeah, maybe you can consider Enterprise Edition. There are some more features, but in our case, one of our objectives was to keep it cheap. Okay, what are the needs from the infrastructure point of view? The infrastructure as a code point of view. You want to have versioning enabled. You would like to know which configuration you have deployed previously. You would like to have the option to roll back your configuration if something is wrong. Regarding the persistent state, you would like to know what you have deployed. Yeah, that's crucial. And as we would like to keep the freedom, we would like to have possibility to deploy to the multiple cloud and multiple cloud providers. Also, it's pretty important that it's configurable, that not with any change you are doing, you need to rebuild something. So there should be parameterized ways of deploying. And for us, what was also very important and can be different for any of you, we wanted to have familiar code-like syntax. What does it mean? We had full-stack developers in our project, and DevOps was not really the part which was most attractive for all of them. So we wanted to find the way how the learning curve can be shortened, and it looks like developing of the code, so the people it will be more attractive for the people. We would like to have a tool where it's active community, so it's easy or it's cheapest if somebody else will do it instead of you. Yeah, you don't have to do it by yourself. And in case there is needed some specific custom deployment, there should be an option how to extend it. Again, we choose Crossplane. Maybe it's not best choice for everybody, and I will try to explain why we chose it. We were considering the other tools like Terraform, Pulumi, or Ansible, and we chose Crossplane. And the main differentiator here was active monitoring state. What does it mean? If you are deploying your infrastructure somewhere, with the Terraform and the other tools, you know how it should look like. You have the state, but you never know whether it was not changed by somebody accidentally or on purpose. Here with the Crossplane, it's different, and Otto will show you on our demo presentation how it looks like. It's actively monitoring your state, and it's monitoring your state as a Kubernetes resource. Yeah. So every infrastructure which you are deploying, and it's not just the infrastructure, it can be even your application. It's represented by infrastructure by a Kubernetes resource on cluster, and you can see what is the state when it was deployed, how it looks like, and so on. Another point for us was open source operators. There is again community which is deploying or developing providers for multiple cloud providers, AWS, Google Cloud, Alibaba, and the other ones. And there is also a provider framework where you can write your own custom operators. So in case you would like to deploy some specific application and nobody will never create for you any operator, you can do it by yourself, write in Golang. So again, there is an active community contribution. So that's always advantage. And it's free of charge, which was our one of main objective. Okay, until now we were talking about the DevOps environment. Now I will be more specific, and it's DevOps cluster, Kubernetes cluster. So, and I will try to explain you why we thinking about the DevOps cluster. First of all, is separation of concerns. We would like to keep separated development and developers' tools from the applications. And we need to some place where our tools will be running. Tools, I mean, our GitLab, as we choose that. We will need to have a space where Crossplane control plane will be running. Because as I mentioned, every deployment done by Crossplane is represented by Kubernetes resources. So in order to have Kubernetes, you need to have Kubernetes. Yes? So there is a chicken egg problem. You need to have really some space where your resources are represented. And Kubernetes cluster also giving us high availability capability. That's nature of the Kubernetes cluster. And specifically for GitLab runners, it gives us the option to effectively use resources, because we can spin up and spin down how many nodes we need based on the development lifecycle or even during the day. If there is a need for many GitLab runners, they are spinning up indefinitely. 20 nodes can be running GitLab runners, so it's not blocking developers at all. And once it's not needed, they are automatically shut it down. So even from the cost perspective, it's much more efficient. And just picture how it looked before and how it looks after. Here on the left side, you see what we had before. It was really a lot of machines. You can imagine each of these virtual machines, they had their own Linux-based image. Each of them you had to take care of, patch them. It was not easy. Some of them, they were set it up manually, and we figured out after restore that it was not spin it up correctly because some mounted drive was not permanently mounted. And you have down your server and you don't know what to do, and there's not really a good documentation. Just here you can see about the, imagine the size. We are talking about the 68 containers, which we moved from the service. We had a couple of application clusters as well. As I mentioned, some project, they shared one cluster. Some of them, they have their own cluster. Even the cluster were not deployed in the same way. Some of them were EKS cluster as a service. Some of them were deployed by COPS. So also not easy to maintain. And here we are talking, if it is full scale, all applications are running, we are talking about 270 containers. So it was 12 nodes. It's pretty huge. And about the cost effectiveness, you can see we were down from 7 to 9K USD to 2.6, 2.8. Yeah, so it was really a good savings. So the first phase, how it looks like. We are, as I mentioned, we are deploying to the Kubernetes cluster, and we are deploying GitLab Community Edition. And we developed something which we originally called Aries BIOS, because our project was Aries, but let's call it infrastructure as code. What does it mean, or how it looks like? At the beginning, you are on the greenfield, you don't have anything, right? So, and we will show it on demo. So you don't have even your GitLab, so you need to somehow work, yeah? So what we have done, we have written this BIOS part, which is minimum set of lines of commands and bash scripts, which are needed to set up your GitLab and your DevOps environment, meaning Kubernetes cluster, install GitLab, one private runner, and single sign-on, and that's it. The rest is directly done in GitLab. There is a bootstrap pipeline. So once the GitLab is set it up, the bootstrap pipeline is executed, and the rest, which we can execute directly from the GitLab, is done there. So as I said, minimum code, and even this code, this infrastructure as a code BIOS, it's maintained in the GitLab. It's just cloned or mirrored to the AWS, but we have just one place where we are maintaining all our code. Achievements, yeah. What were our achievements? As we are using Helm for deployment and GitLab has native Helm support, that means that for full production ready release of the GitLab, you need to just configure a couple of YAML files and that's it. In full production, I mean, originally we had running Omnibus version, which it has limited capabilities. It's all in one container, so not really scalable. This version can support from tens of developers till thousands of developers, so it's really scalable. And what also helps us is we are using AWS Spot instances. I'm not sure if you are aware of, I just briefly, it's a virtual machine where you do not have guaranteed availability, and that means that if there is a high load in AWS, you are noticed 2 minutes in advance that your machine will be shut down, and you need to handle it. But with combination with AWS termination handler, we are notified and we know that we can spin up different type of virtual machine, which is available and for the best price. So the developers, they do not even recognize that something happened. And that's also the nature of the deployment of GitLab by Helm. All services are high available. They're duplicated, more order services. This is a microservice architecture, and all core services are run at least twice. So if some of the services is suddenly crashed, then the application is running and you do not recognize it. There is also a benefit if you are doing upgrade of this GitLab. It's not zero downtime, but it's close to the zero downtime. Yeah, so it's easily to upgrade. With this setup, we were able to create new DevOps environment in more than 30 minutes, but 33 or 36, right, Otto? That means fully new environment in region you wish, and with the initial installation of the GitLab. With disaster recovery, that means a backup of the GitLab, or the restore of the backup of the GitLab. It took 55 minutes, and we will show it in our demo as well. But that means that all your projects are already there, and you are able to work. Yeah. And in our case, backup had about 5 gigabytes, so it was pretty huge backup. Yeah. About the phase 2, we will have demo here as well. We are using Kubernetes and Helm as before, and here we are using Crossplane and Crossplane composites. The process is following. There is a defined approval process. So user who would like to have set it up application cluster, he will create a request. The request is approved, and once the request is approved, it's stored in a Git repository, and then the cluster is spinned up via Crossplane composites. It's fully automated deployment of the cluster, and users doesn't have to go to the AWS account. For this part, it's not needed. Just the very first part, when you are setting up your new DevOps environment, you have to go there because you need to be somewhere, right? Here we are using, again, spot instances because for our case, it's perfectly fitting. And by the Crossplane composite, I mean, or the Crossplane composite is a group of resources which we are to deploy together. We call it, I think, AKS cluster or RS cluster, AKS. And that means it will set up your virtual VPC network, your virtual private cloud. It will connect your new virtual private cloud by peering to the existing infrastructure. It will set up load balancer, EKS cluster. It will set up Kafka operators, so our application can easily deploy new Kafka streams. There are some tools for monitoring which we decided to use, and we are using Grafana, Prometheus, and Loki. You can use Elasticstack if you wish. For us, this was, I don't know. We chose this one. We liked it a bit more, but it's a different discussion. There is deployed service mesh. We have shared databases because all our applications are using same databases, and from cost perspective, for our case, it makes sense. So we're deploying various databases like Cockroach, Redis, MongoDB, Scylla. We are deploying observability tool Jaeger, and we are deploying change data capture software Click Replicate. With this setup, if you just click on the creation of the application server, it also registers your DNS record. So you are just define where your cluster should be available, and in Route 53 in AWS, it will create the record. It will integrate it, in our case, it's Accenture Active Directory, and it's immediately available. So after installation is done, you can immediately use this cluster, and you can create them as many as you wish. About the application deployment, I think this is more or less standard CI/CD. You probably know that it contains the static code analysis, some unit tests, building containers, configure API gateway, register URL path because you already have your URL and your application needs to run on some path, and you are deploying bounded context. It's per application. What is a bit different, and we didn't have it before, we are using ephemeral namespaces. You can imagine that in some cases where user cannot test something locally and you would like to test it on the server, or there should be merge request, or there is merge request which should be merged, you can check it directly on the server. So based on the user enterprise ID, there is created a new namespace with the lifespan 2 hours, and user can go to the server and check what is going on. If you would like to prolong it, he can stop this counter, so it will be taken for a longer period. And at the end of the week, there is a job which will just clean up those environments which were there for a longer time. And I think that was enough from my side, right, Otto?
Yes, definitely.
Okay, now we will have a demo, so I will hand it over to Otto.
Thank you, Rob. So yeah, I will show you a live demo which has been pre-recorded because of time the infrastructure actually takes to be provisioned. In this demo, we will actually simulate disaster recovery scenario. So like the whole AWS region is gone, and we need to quickly build up completely the environment from the scratch, including restore of the GitLab repository. So let's start with the DevOps environment. So first of all, we can have a look that the URL is not working yet. So we go to the AWS console and look up our S3 bucket for GitLab backup, which is actually a cross-regional backup, so it will be available over multiple regions within AWS. I need to take this name of the S3 as we will use it as parameter in our pipeline. Here we'll first actually run the pipeline in a code build. We choose a code build in AWS, but could be replaced by any external pipeline. But this time, yeah, it's easier to actually use this one. We are in AWS environment. We start this code build with parameters where we define this recovery S3 bucket, and also we could choose a different region if necessary. And the pipeline will actually start provision basic infrastructure, starting with the VPC. Robert actually mentioned it will prepare repositories for the tools for charts and of downloading the Helm charts, and the infrastructure setup should start every second. Okay. So yeah, so in this case, yeah, now we are already waiting for the cluster to be created. So that means we have already networks, the network infrastructure cluster is being created, node groups, security groups has been already created, and we are going to select or specify the EC2 instances, and yeah, we will switch to the console, I think. Okay, so at this point, the cluster has been, EKS cluster has been provisioned already, and we are going to provision over the pipeline is going to provision worker node groups. So as Robert mentioned, there are two node groups. We will have a specific node group for worker for workload, and specific for the GitLab runners. And in the end, we can see that we also store the it's always quick. Yeah, to control the video in, yeah. Okay. So yes, at this point, the GitLab has been already restored on no, the provisioned and the restore of the backup is running, and in 55 minutes, yes, we have already also the restoration of the complete GitLab without the container repository, so only code pipelines and everything. So from here, we will need to deploy additional software on that on that cluster. So we are going to build a container for Helm, actually, register or create the runners, project-specific GitLab runners, install the Crossplane, control plane, and the providers, and other tools used in the development pipelines like SonarQube and also the Helm itself. So during this step, we will already deploy the Crossplane composite that actually defines our application cluster that we will then build in the next step. So the DevOps cluster already contains definition of the infrastructure of the application. Okay, so this is end of the DevOps cluster build, and we are now ready to go for the application. Oh, where's my video? Yeah, yeah. So we could have a look what is already deployed in a term of Crossplane on the DevOps cluster. So we get a couple of configurations. So the provider configurations, provider revisions, and the configuration package. Oh, it every time goes wrong. Yeah. So once again.
Just one point, the key and kubectl,
Yeah, that's alias. So we always set up the key. Okay, click somewhere.
Okay, I will do. Just tell me.
Please control it for me. So yeah, so the configuration, the package, configuration package for the Crossplane itself is already there. So the developer logs into the GitLab and goes into application cluster project, where he will actually run the pipeline in order to request new environment. So with this, within the pipeline parameters, he specifies the cluster name. Yeah, same.
Not different.
But same result. Specifies environment, the URL, and so on. And by running this pipeline, we will just create the request, which yeah. Wait.
When you lose actually cursor, controlling the video and from
They don't hear. So in this case, it will, yeah. Where are we?
This is pipeline for requesting of the
For
cluster.
requesting, yes. So when next step is that the supervisor with the elevated permission logs into the same GitLab and finds these resources project and merge request inside, which is actually the request to provision the cluster. Can go inside into the merge request, review the changes, look who actually created the merge request, and approve it and merge it into in the repository. This merge will actually start the pipeline that already builds or runs or creates actually it creates the Crossplane claim, so called, and this claim means that we won't take the configuration which has been deployed to Crossplane and create a new environment or new instance of that configuration. So First, yes, we see at this point that our URL is not existing anymore because it's not being recognized. And so go to the pipeline, but yeah. Okay, we already can see that the EKS cluster is being created. And now it's completely controlled by the Crossplane. So Crossplane, through its providers, actually invokes the AWS API and creates the environment there. So this is all the resources that represent in the Kubernetes cluster that represent physical resources on the AWS side. And but not only those, but also we have here like Helm releases. So it's combination of physical resource networks and cluster and nodes and everything together with the applications that we want to actually deploy on that application cluster. So yeah, here we see already that the basic network objects have been created. So we have OpenSlava VPC. And let's wait a little bit for, and the cluster should be already being created. So it's being provisioned. After a while, we can see that it's active, and immediately the node groups is being created. And after another shift in the time, we can see that node group is also provisioned with the nodes. And we have a basic Kubernetes resources already available here. The access is created or provisioned in the background as well. And now the rest of the applications defined in the composite are going to be, deployed. So the pipeline is waiting until all of the resources are provisioned, and then it saves. It finished with some post steps because not everything is possible in Crossplane at this point. In general, we are complete with the pipeline. So now our OpenSlava cluster is available, and we can open the URL, which actually is already recognized. So we get the IP. However, there is no like default workload. So we get a 404 from the engines, but please go. And we can open Grafana, for example, and see the intro page of the dashboard. And yeah, we are complete. So this one takes about, I think, 30 minutes. So in 30 minutes, we have completed the application environment.
We'll do the live.
Yes, so we want to demo how actually we need to log in, right? So let's have a look how the active monitoring works. Because, for example, with Terraform, if you provision the infrastructure and you change it, it won't be remedied by automatically. So in the So I connect to the DevOps cluster, and I can check. Okay, let me go to the. Where do we have my browser?
Right.
Oh, sure. So if I go to the AWS console. Yeah, I will. So in EKS, we have cluster, and for example, let's take this associated security group. So let's look at the outbound rules. We could see two rules there. So let's accidentally delete one of them. It's okay. So yeah, and yeah, in a few seconds you could see that it gets recreated because Crossplane is actually monitoring the state, and if the state is not as defined by the composition, it will actually return it back.
Benefit here. So the benefit here is that there is no way that somebody will change your security groups
or anything. Even application. Yeah.
So your node state is not different what you are expecting that it's there. So if somebody needs to do there some change, he cannot do it directly here because it's not possible. Yeah? If he will do that in few seconds or minutes, it's reverted back. So everything needs to be defined as a code. So it's really pushing you to not do direct changes somewhere, but really do it as it should be.
Yeah.
I think we are out of time, right? So
do we have questions?
Do we have questions? Is this approach also applicable if my application are using serverless approaches like AWS Lambdas?
Approach for using Crossplane, or is it?
Yeah, there is several.
Generate.
Yeah, there is several parts or areas, and some of them definitely can be used. Some of them can be adjusted. Yeah, it's a approach, and it's up to you what you consider you can take it, and something maybe is not applicable. Yeah, so it's not guidance for everybody, but it's just the way how it can be done. Have you considered Terraform to bootstrap the EKS cluster? That's also the option. Yeah, could be. Yeah, we are using AWS code pipelines or code commit, and we have just several steps there. It can be done even with Terraforms. We are using EKSCTL, right?
Yeah.
Command there, but yeah, can be even improved. Yeah, we are not saying that this is the only way how it can be done. It can be even improved. I don't know. Why there is mentioned downtime? Where? It's a bit late. I mentioned downtime for the upgrading of the GitLab.
GitLab upgrade.
Originally, when we had GitLab Omnibus, it was not always easy to upgrade. We were never sure whether it will be spin it up back, and the downtime was longer. With this configuration, even GitLab is saying it's very hard to get zero downtime for during the GitLab, but we are talking about the seconds. Yeah, so it's replacing web service by web service, Gitali server by Gitali server. So there everything is duplicated, and even during the upgrade, you see we are doing the refresh. Sometimes you are routed to the old one and sometimes to the new one. Yeah, so it's in the middle of in the measure of a couple of seconds, it's completely upgraded. So we never had such smooth upgrade experience before like we had now.
Imagine you have like 50 developers working with that GitLab. You can just have a downtime in hours. Of money.
CDK, I'm not sure whether it's what I think it is. There is something which we have to take it offline. I'm not sure. There is something where some AWS service, I'm not sure which one, was inspired by the Crossplane, and they're doing very similar stuff. And what I understood at that time when we were considering this one, that they were not so far as a Crossplane was. Yeah, but I'm not sure what is the CDK, to be honest. Did you also implement?
Really?
Did you also implement some transformation in the applications deployed, or just change the runtime from VMs to Kubernetes? Are we talking? We were in the Kubernetes even before our applications were running in the Kubernetes, so there was no change at all. And about our DevOps environment, we changed it from the virtual machines to the Kubernetes. But our goal was not, or when we are creating the application, we do not have time for improving them. We are supposed to keep them running, and we are creating new and new applications. So just kind of a demo proof of concept. So in our case, that was a different situation. Yeah. But as I said, we were already deploying to the Kubernetes cluster, so there was no change. Yeah, it was always microservice architecture. Everything was deployed in the Kubernetes cluster, just different one. The clusters were created differently. Yeah, we were testing Argo CD in the past, so it was changed in the meantime, and we were thinking about that. And that's also an option to use it in combination with Argo CD. Maybe for some bigger implementation, it makes sense. Yeah, there is also definitely an option to combine it with the Argo CD. Yeah. Why is the resource there? I don't know which resources do you mean. Why there are resources that are managed by pipeline and not by Kubernetes operators? It's always we are short of time. It's always about the time you have for that, and you need to do some research. We were using Crossplane on every places where we could. It's even in the time it was evolving. At the beginning, for example, we could not create flow logs for EKS cluster. Am I right? And now it's supported, but
now it's supported.
Yeah, so it's really in early stage of development, even the Crossplane. So not all tools are done there. If they are there, then we are using them. If they are not there, then we are waiting, and we will do it later on once it will be established. And the last one, why did you choose the solution with a lot of IS components instead of platform as a service? We wanted to have a freedom. All our tools which we are using are open source versions, and you can deploy it on premise if you need. You can deploy it to any cloud provider. So that was our main course. We didn't want to pay for anything. We want to keep all open source softwares as much as possible. And yeah, we wanted to...
And platform independent.
Platform independent, exactly. Yeah, thank you very much. Thank you for joining us.
Thank you, guys.